Hi everyone, for this lesson I'll show you how to measure angles. So we have an angle here that's made up of two rays and they share the same endpoint, and this endpoint is known as the vertex, and these are the two sides. Alright, so now if you look at the angle, I labeled the points B, A, and C. So A is the vertex, and then we have ray AB and ray AC. And we can name this angle angle BAC, or we can name it angle CAB, but you have to put A in the middle, right? Because that's the vertex. You can also call this angle 1, indicated by the number 1, which is inside the angle here. So we can actually call this angle 1 also. Okay, so if you look at this diagram, you can actually define the different region of the angle. So the shaded region here is known as the interior, and everything else is known as the exterior region. So for this diagram, we have angles 1 and 2, and we have angle JMK, which is the same thing as angle 1, and we have angle KML, which is the same thing as angle 2. So now let's take a closer look at angle 1. And if you notice, it's the same thing as angle JMK, which is this one here. And you can reverse the order of the letters. You can write it as angle KMJ, which is this one here, and it just represents the same angle, which is angle 1. Now if you look at the second angle, angle 2, you can write that as angle KML, which is this one here, or you can reverse the order. You can write it as angle LMK, which is this one here, which represents angle 2. Alright, so we're ready to take a look at our first angle postulate, which is known as the angle addition postulate. And that means if you to look at the two angles, angle 1, and if you were to take angle 1, or the measurement of angle 1, plus the measurement of angle 2, you'll get the measurement of angle JML. So let's do a numerical example. Let's say that the measurement of angle 1 is 55 degrees. And the measurement of angle 2 is 50 degrees, and we want to find the measurement of angle JML, or the measurement of angle LMJ. Well, we know that measurement of angle 1 is 55, so let's substitute that in there, and the measurement of angle 2 is 50. So therefore, the measurement of angle JML is 105, or 105 degrees. Alright, so now let's take a look at a different problem, but using the same diagram. Let's say that angle 1 is given as this expression here, 3x minus 7 degrees. And then angle 2 is given by this expression, which is 2x plus 8. And it's given that the measurement of angle JML is 111 degrees. So we want to set it up in a way so that we can find x. So according to the angle addition postulate, if we were to add up angles 1 and 2, or find the sum of angles 1 and 2, it will equal the measurement of angle JML. Right? So let's set that up. We'll say that 3x minus 7, and we would to add that to angle 2, which is 2x plus the 8, and that's going to equal the measurement of angle JML, which is 111. Right? So now we can simplify this to 5x, because 3x plus 2x is 5x, and negative 7 plus 8 gives you a plus 1, and that's equal to 111. And now we do minus 1 to both sides, and we'll get 5x is equal to 110, and then divide both sides by 5. So x comes out to, let's make a little bit of room here, x comes out to 22. Once we know what x is, we can actually plug it back into each of the expressions here to find the individual angle. So if you were to plug x back into this expression, you're going to get 59. And if you were to plug x back into this expression, you get 52. And we can check that 59 plus 52 is 111. So we're good. And that's the end, and we're done, and we're happy.